Hello everyone. Today I am taking the structural mechanics subject's topic, which is shear force and bending moment diagram of simply supported beam. The subject is important for civil engineering students as well as mechanical engineering students. And every time this comes in exam and as well as an SSC exam and state PSU exam also. So this question is very important for every point of view. So before explaining this shear force and bending moment diagram, let me tell you a brief description about the beams. So there are basically 6 types of beam. First one is cantilever beam. Let me show you. This is cantilever beam. Second one is simply supported beam. In cantilever beam, one end is fixed and another end is free. This is the beam, cantilever beam, and this is the support. So this one support is fixed support and the beam is this one. So at free end, one point is free and another is fixed. This is cantilever beam. Second one is simply supported beam. In simply supported beam, this beam is supported simply over the support, two support. So this is simply supported beam. Third one is fixed beam. In fixed beam, the both ends are fixed. This is third condition. Fourth type of beam is overhang beam. This type is overhang beam. If a beam is simply supported and extended toward from the support, then it is called overhang beam. So overhang beam have two conditions. One is one side overhang beam. The second one is both side overhang beam. So this is fourth condition. Fifth type of beam is a continuous beam. Continuous beam is a beam which will have more than 2 supports. So this will have 3-4 type of support, 3-4 supports. So this is continuous beam. And sixth beam is propped beam. This one beam is called propped beam. If cantilever beam is will provide us propped support at free end, then this is called propped beam. So these are the types of beam, 6 type of beam. Now I want to tell you types of loading. So there are basically 3 types of loading. First one is point load. We will show point load this way. Point load, which one is this? 2 kilonewton, 6 kilonewton, and the unit of this is we will show in kilonewton. The second one is UDL. The meaning full form of UDL is uniformly distributed load, and it's shown in this way. And the unit we will take it as 2 kilonewton per meter. This way. We will write it in this way. 2 kilonewton per meter. In point form, we will just write it in kilonewton, like 1 kilonewton or 2 kilonewton. In UDL, we will write it 2 kilonewton per meter. The unit is kilonewton per meter, right? And third one is varying load. In varying load, suppose this is a beam and the load is varying from this one point to, and it is increasing toward another point. So the load intensity is increasing from this point to this point. So this one type of loading is called varying load. Okay. So we read about the now today we are taking the load combination is a simply supported beam and point load condition. Simply supported beam and point load. Okay, so let us take this. Here is a beam. The question will be given in this form. Here is a beam, simply supported beam A, B, and the point load is working over here 2 kilonewton, 6 kilonewton, 3 kilonewton, and find out the shear force diagram and bending moment diagram of the simply supported beam. So first of all, what we have to do is we have to draw this diagram, this beam diagram, and we left blank for that below portion, so that we can easily draw the shear force diagram and bending moment diagram. From the next page, we will start the reaction and all these things. So basically, I divide these questions in 3 parts. First one is reaction, second one is shear force diagram calculation, and third one is bending moment diagram calculation. This one is bending moment diagram calculation. These are three easy steps of to find out the shear force diagram and bending moment diagram of simply supported beam. So let's take, first of all we will find out the reaction of point A and B. Here is what? The AB is support. AB is support. Point A, this one is support and this one is support, and it is beam. It is beam. And at point C, 2 kN point load is working. At point D, 6 kN point load is working, and at point E, 3 kN point load is working. So here is, this is known, this is known, this is known, and A and B reaction is unknown yet. Okay, so what we will do, first we will find out the reactions. So in this condition, Ra plus Rb, this one is reaction, R basically is reaction Ra, and this is reaction Rb. And Ra and Rb is resisting the whole load which is coming from downward, which is coming downward. So Ra plus Rb equals to 2 kN, 6 kN and 3 kN, which is 11 kN. So Ra, first equation will be Ra plus Rb equals to 11 kN. Okay. These two are unknown, so we require more equation to solve to find out the value of this. So what we will do, we will take moment about A with respect to B, taking moment about at point A with respect to B. Okay, so what we will do, look at here, Rb, this one is Rb into, this is 2 to 4, 6 to 8. This is 8 meter distance from A. We are taking moment at point A. Okay, and this is this way. The reaction is working here. It is making moment for this. So Rb into 8 distance equals to 3 into 6, 2 to 6, 2 to 4 and 2 6 plus 6 into 4 plus 2 into 2. So Rb into 8 equals to 46. Okay, so we will find out Rb by 5.75 kN. Okay, this way we got the reaction value of Rb. So now we will put the value of Rb in equation 1. We will get the R. Now what we get? We get the Rb, reaction value of Rb is 5.75 kN, which is working upward. And this, because this is support, so this will definitely work in upward direction. And here reaction Ra at this point, support A is the value is 5.25. Okay, so now we get the value of Ra and Rb. And now this is step first. Step first, we have already find out the value of Ra and Rb. Now we will go for equation number 2, step number 2, sorry, which is shear force diagram calculation. In shear force diagram calculation, one thing you have to remember, and that is the sign convention. This is very important. And before sign convention, let me recall you the definition of shear force diagram. Shear force. The definition of shear force is, it is the algebraic sum of all the vertical loads acting on the either side of the section. Means it is the algebraic sum of the vertical loads. This one is vertical load 260 and this one is also vertical load. And this is the algebraic sum of the loads working on the either side of the section. Right? So if suppose we are taking the point D section here, so we will take right side of the section and all the equations. So algebraic sum will be 3 kN and 5.75 kN. So algebraic sum will be 2.75. So this is the definition of shear force. Similarly, the definition of bending moment is, it is the algebraic sum of all the movement working on the either side of the section. It is algebraic sum of all the movement working on the either side of the section, either right side or left side. So here we are taking the shear force diagram calculation. Shear force at point B. Here we will take the shear force at point B. We will start from right side. Shear force at point B. And sign convention. We are talking about sign convention. So we are taking this one is section, suppose the load which will come downward from the right side of the section, this one is section, and right side of the section downward load we will take negative and the upward load we will take positive, right? So this is sign convention we will take. And one more thing, here we have shown some arrows. The meaning of these arrows is, meaning of this is just before and meaning of this arrow is just after. Just before and meaning of this arrow is just after. We have got here a lot of arrows like this. Here is just before, then just before. At every point we will take just before and just after arrow. Okay. So this sign convention is very important. Because of this we can calculate it very easily and very these required for, because hopping and sagging may occur in beam. So this sign convention is very important. Okay, so we will take here RB. First of all, we will find out the shear force at point B, just before. Let's take here, just before shear force is 0. Here is 0. And just after, this one reaction is working. This one reaction is working. So just after one will be 5.75. Now look at this load is working upward direction, and upward direction is positive. Upward direction is positive. So we will take here shear force at point B just after is 5.75 kN. Okay. Now we will take shear force at point E just before equals to 5.75 kN. See, point E just before, the only 5.75 kN upward direction load is working. Other than RB, none of any load is working from the right side of the section. Right side of the section means the point which is we are taking. So we are taking here at point E, and the right side of the section is just 5.75 is working. So shear force at point E just before, this one I am showing just before is 5.75 kN. Now shear force at point E just after equals to 5.75 kN. This one is working upward direction, so we have taken it in positive, and the 3 kN is working downward, so we have taken this minus 3 kN. Here is downward load is minus, so we have taken this minus. So 5.75 minus 3 kN is 2.75 kN. This is the unit of shear force. Obviously it is a force, so we will write it in Newton or kN. So here is 2.75 kN. Now shear force at point D, and here again just before. At every point we will take just before and just after. So just before same as at point E, because here is the same 3 kN is working from upward direction and 5.75 is working from downward direction. Downward to upward direction. Okay, so 2.75 at point D. Now shear force at point D. Look at here. Shear force at point D just after the 6 kN working load is working what? Downward direction. So here we will consider again. Remember the definition of shear force. The algebraic sum of the all loads working on the either right side or left side of the section. So we are taking the right side of the section, and the right side of the section 5.75 is working. Look at, which is positive upward direction, then 3 kN downward, and then 6 kN again downward. So algebraic sum is minus 3.25 at point D just after. Now at shear force at point C just before is again the same, which was at point D 3.25, which was at point D. Okay, and shear force at point C just after again this load will be considered. Okay, shear force at point C is 5.75 minus 3 minus 6 and minus 2, which was at just at point C. So which is 5.25 value. Now one thing you have to remember, at the end point when you will calculate the shear force should become which is equals to reaction at point A. Okay, so look at shear force at point A just before was the same as just after which was just after C. So which is 5.75 minus 3 minus 6 minus 2 equals minus 5.25, which is equals to reaction. which is equals to reaction. 5.25. Look at it. Okay, so it is minus 5 kilonewton. Okay, kilonewton and kilonewton. I have seen that kilonewton. So minus 5.25 kilonewton. So minus 5.25 kilonewton just before A, and just after A it will be 0. So one thing you have to remember here, in case of simply supported beam, at the shear force at the reaction point, and just after will be 0. Just after will be 0. At the end support shear force will be 0. Okay. So now we have calculated the shear force diagram calculation. So we can draw it first. Okay. So you have to do? You have to extend all these lines this way, this way, this way, this way, and this way, and just you have to draw a line which will be 0 kilonewton line. Okay. So now these values come from different points. So we will plot this one in here. So we will take a scale to plot this one accurately. Okay, so we will take 1 kilonewton. 1 kilonewton equals to 1 centimeter, so that we can plot it like 5.75. We can take it on scale. Okay, so this is just for just to show it proportionately. Okay, so we will draw it now. Say force at point B, it is 0. At point B, it is 0 kilonewton, and then shear force at point B just after 5.75 kilonewton, which is positive. So this one is side is positive and this one is negative. So 5.75. This one is 5.75. This one is 5.75 kilonewton. Okay, kilonewton. Now at point E, this one is point E. Just before is 5.75. Same 5.75. We will join this line. This one is 5.75 kilonewton here. Okay, and just after shear force at point E, just after is 2.75 kilonewton. So from here 1, 2, 3, and 2.75 is here 2.75. That's why we have taken the scale, so that we can plot this proportionately. If 1 kilonewton is 1 centimeter, so we will take the line of 2.75 kilonewton and we will plot it here 2.75 kilonewton. Okay, and now shear force at point D. Shear force at point D just before. Again, this is same 2.75 kilonewton, so we will join this line to this one 2.75 kilonewton. And shear force at point D again just after is minus 3.25. So minus we will take it downward direction. Means lower than this line. So minus 3.25 here. 3.25 kilonewton. So we will join this line this way. Minus 3.25. Again at point C, shear force at point C just before is minus 3.25. Just before shear force at point C just before minus 3.25. Again minus 3.25. We will join this line. And shear force at point C just after is minus 5.25. Minus 5.25. Okay. This one is 3.25 kilonewton. So, and at point A, just before, shear force at point A, look at here, shear force at point A just before is 5.25 kilonewton. 5.25 kilonewton, and shear force at point A just after is 0. As I have said, and the support, the shear force will be 0. So here is shear force diagram. Now further we will plot this way. This one is positive SFT and this one is negative SFT. Okay guys. So this one is shear force diagram. Now we will calculate the bending moment diagram, bending moment at different point, and then we will draw the bending moment diagram. So again we will start the bending moment from right side of the section, from right side of the support. So bending moment at point B is 0. Obviously what is bending moment? Bending moment is the load and the distance from that particular point. So here is at point B, just load is working and the distance is 0. So RB, bending moment at point B is 0. Now bending moment at point E, RB and 2 kN. Again here is we have to consider one thing. Which is sign convention. Every time you have to show the sign convention to it. Every time you have to write the sign convention. So in this case, we are taking the right side of the section. Again, the clockwise is negative and anti-clockwise is positive. Right? So as you know, the definition of bending moment is it is the algebraic sum of all the load, all the moments working on the either side of the section, either right side or left side of the section. So now we are calculating the bending moment at different point. So bending moment at point B is 0. Bending moment at point E is now look at here 5.75 and the distance is 2 meter. 5.75 and 2 meter. Now look at this B. This reaction is taking movement at anti-clockwise direction. So we have taken this as a positive. Okay. So bending moment at point E is 11.5. Now the question arises, why you have not taken 3? We have taken 3 km, but the distance is 0. So this is 0. So we don't write this. Okay. So 5.75 into 2 is 11.5 km. So bending moment at point E is 11.5 km. Now bending moment at point D. Bending moment at point D. Now consider this 5.75 and the distance is 2 to 4. Okay, 5.75 into 4, and this is showing movement is anti-clockwise direction, and now the 3 km is taking movement as clockwise direction. So we have taken 5.75 into 4, which is here 5.75 into 4, and minus 3 is taking movement in clockwise direction, 3 into 2 meter. So which is 17 km. The unit of bending moment is km. Okay. Now bending moment at point C. Bending moment at point C is 5.75 into 6. This is distance, minus 3 into distance is 2 to 4, and 6 into 2. So this. Okay. So algebraic sum is 2.5 km. And bending moment at point A again is 0. If you calculate all these things, bending moment at point A, it will come 0. How? Let me show you. Suppose this is 5.75 into the distance is 8, and this is working as a clockwise direction. So 3 into 6 minus 6 into 4 minus 2 into 2. So this will definitely come 0. So this will definitely come 0 km. Okay. This will come 46 and minus 18 minus 24 minus 4, which is 46 minus 46. Okay guys, so suppose at point bending moment at point A is, from the calculation is 0. So now we will plot again the bending moment diagram. This was the static shear force diagram. And now for bending moment diagram again we will plot a 0 kilonewton meter line. 0 kilonewton, as we have plotted the 0 kilonewton line in shear force, similarly we will plot the 0 kilonewton meter line in bending moment diagram calculation. So now take the different point of bending moment. Bending moment at point B is 0. Here is 0, which is B. Okay. Bending moment at point E, which is 11.5 kN. E. This one is E point, and here is 11.5. So to make this proportional, again we have to take the scale here. 1 centimeter equals to 1 kilonewton meter. Okay. Or you can take 2 kilonewton meter proportionally. So you can make it accurately on book or copy or answer book. Okay. So bending moment at point E was 11.5 kilonewton. Is now suppose 11.5 kilonewton on that. 11.5 kilonewton meter. Okay. So this will become tapered line. This will be joined by tapered line because the bending moment in point load condition, the shear force will be a straight line and the bending moment will be tapered. In the UDL load, it will be considered as parabolic line. Okay, we will discuss it further. So now shear force at point B, bending moment at point B is 17 kN. Here is 11.5 and 17 will be somewhere here. 17 kN. Okay, so we will join this line this way. Okay, 17 kN, and bending moment at point C is 10.5 kN, which will be near 11.5 is here. So 10 kN is 10.5 kN will be here. We will join this line. Okay, and at the end point, bending moment at A 0. We have tabulated this one also, and which is come to 0. Okay, it's come to 0. So now we will join this line. So this is the bending moment diagram. Okay, and we will show this way. This is positive B and B. Okay, so guys, this is the shear force and bending moment diagram of simply supported beam with point loads. Further, we will discuss the UDL load and some other load combination for cantilever, for simply supported beam, overhang beam also. Okay, and this one is my first video, so please comments me if any correction required. Here sound system is not good, and we are working for that. Further, we are working for that, and we will improve this. Okay, so thank you so much, guys.